Good evening, students. In today's class, let us discuss about the non-ferrous metals such as aluminium, zinc, copper, lead, tin, etc. So first we'll see the aluminium and its alloys. Aluminium is a non-ferrous metal which is extracted from the ore bauxite. Bauxite is the ore which is available on the earth, and from this bauxite ore the aluminium is extracted. So aluminum is a white or whitish gray in color. So the color of the aluminum either white or whitish gray. It has a melting point of 660 degrees centigrade. At 660 degrees centigrade, aluminum starts melting. Aluminum has high electrical and thermal conductivity. It is a good conductor of electricity and heat. So it is soft and ductile and has a low tensile strength. So it is soft and ductile and a lighter material and a low tensile strength. Aluminum is very widely used in aircraft industries and fabrication work because of its lightness. This is used. Aluminum is mainly used in aircraft industry since it is light. So the aeroplanes, flights and all, the body of the aeroplanes and all manufactured from aluminum. And second one is fabrication work. This is for door windows, shutter doors and all. Its application in the electric industry is also on the increase. Its application in the electric industry, it is used since it is a good conductor of electricity. It is used as wires in the electrical industries or appliances, coils and all. It is also very much in use in household heating appliances since it is a very good conductor of heat. So it is used in kitchenware utensils, vessels and all. Some typical aluminum alloys, their composition applications are given in the table that follows. So some of the application, different types of composition of aluminum by adding other metals and alloy metals are made, and such metals which are used for different purposes, and this is given in the chart is given in the below. So it is depend upon the percentage of the other metals such as copper 0.1%, silicon 0.5, iron 0.7, manganese 0.1, and this type of aluminum is called wrought not heatable. Fabricated assemblies, electrical conductors, food, brewing, processing plants, architecture, decoration, etc. It is used in fabrication work for the windows, shutter doors and all. Then electrical conductors, food and brewing, food preparing vessels, containers and all, and architecture for decoration purpose. The next one is copper 0.15%, silicon 0.6, iron 0.75, manganese 1.0, magnesium 4.5 to 5.5%, and other elements such as chromium 0.5%. So this also wrought not heat treatable, high strength shipbuilding and engineering products. It is construction of the ships, body of the ship is constructed by this, and good corrosion resistance. It is not corroding in the salt water. Good corrosion resistance. Next one is 1.6% of copper, 10% of silicon, and the remaining percentage is aluminum. So this is used general purpose alloy for moderate stress pressure die casting and for casting of the dies, die casting, aluminum die casting such as a vehicle clutch, clutch handle, such type of castings are made from this material. Next is 10 to 13% of silicon, and the remaining percentage is aluminum is used for widely used in alloys suitable for sand, gravity and pressure die castings. Excellent foundry characteristics for a foundry for molds, which are preparing for molds, vehicle engine body parts. For this is used, and also used for large marine, automotive and general engineering castings for general work purpose. The next one is copper 4.2%, silicon 0.7%, iron 0.7, manganese 0.7, magnesium 0.7, titanium 0.3 if it is optional, and remaining is aluminum. So this it is called duralumin, general machining alloy, widely used for stress components in aircraft. Then next one is 0.5% silicon, 0.6% manganese, and remaining is aluminum. It is a corrosion resistant alloy for lightly stressed components such as glazing bars, window sections, automotive body components, window sections, shutter windows, and automotive body components. The next one is 1.8% copper, 2.5% silicon, 1% of iron, 0.2% of manganese, and 0.15% titanium, 1.2% nickel. This is suitable for sand and gravity die casting, high rigidity with moderate strength and shock resistance, a general purpose alloy. So this is gives a good strength material. This gives good strength for material, and strong rigidity is there, high rigidity is there, and shock resistance also there. Suddenly if the shock is falling also, nothing will happen to this material. Next, manganese 10.5% and 0.2% titanium, remaining is aluminium. So this is also a strong ductile high corrosion resistant alloy used for aircraft and marine castings, both large and small. So this type of material is used in aircrafts, construction of the planes, then construction of ships, boats and all, for the corrosion resistance property, and this is used for such purpose. The next advantage of using aluminum over steel. Advantage, it is compared to steel, it is lighter, very light material, strength comparable to steel. So that strength comparable, but it is not equal to steel. So that much strength it doesn't give. Then corrosion is, it is not corroding. In salt water or anywhere it is not corroding. Good machinability. Machining is easily can be machined since it is ductile and soft material. Can be anodized. Then better thermal and electric conductivity. It is one of the best quality of the material, that is a thermal and electrical conductivity. Good conductor of current and electricity. Current and heat. Next, disadvantage, less strength compared to the higher strength steel alloys. Compared to steel and other alloys, this is a less strength because it is soft. Not good for threaded fasten, because any component, this aluminum is used for cutting threads and all. For such job, the threads are not properly finished because it is not producing a good threads. More difficult to paint. Then weldments require post welding heat rate to recover mechanical properties. So after welding again, once again is heating is required for recover the mechanical properties, because while welding the properties of the mechanical properties may lose. So to recover that again heating is required. More difficult to weld. Fatigue, that means it is not used for heavy work and all. High cost, cost wise also more comparing to steel. Lower modules of elasticity, therefore increased deformation. Low elongation values, so elongation is very less. Aluminum and its alloys. Aluminum is one of the most widely used metals in the world. It possesses an exciting range of properties. Moreover, aluminum combines with the alloying elements like copper, manganese, silicon, manganese and zinc, magnesium and zinc, and forms a very useful series of alloys. So important properties of aluminum. So aluminum used for other metals also, adding to other metals and preparing a alloy metal. Aluminum is a lightweight metal. Its density is about 2.7 grams per cubic centimeter. It is about 1/3 of its light as steel. That means since the uh, density is less, so that material also lighter in weight, and is comparing to steel, it is just 1/3 of its density. While pure aluminum has low strength of 7 kg force per mm squared, the alloys are moderately strong. Some alloys have strength as high as 45 kg force per mm squared in the heated condition. The above two properties together provide it with the high strength to weight ratio, which makes it suitable for aerospace application. For satellites and all, this aluminum is used. Some of the alloys have excellent toughness at a low temperature, making them suitable for cryogenic below application. Some alloys have excellent corrosion resistance. Aluminum and its alloys have high thermal conductivity. Aluminum and its alloys also have high electrical conductivity. So electrical thermal conductivity is a good, both are the good properties of the aluminum. Application: household furniture and utensils. For household furniture, kitchenware, utensils and all, this aluminum use. Containers, tanks and vessels. It is used for manufacturing containers, tanks, vessels, since it is not corrosive. Then automobile structure, bus bodies, road and railway tankers and wagons. So automobile structure, since it is light in weight, it is used for vehicle bodies, then railway tankers, wagons, building and other architectural structures. Since it is can be molded to different shapes, So it is used for decorative purpose, architectural process, architectural application. Then portable bridges, small bridges and all, folding bridges, aircraft, missiles and other aerospace components. Since the weight is very less, it is used for aircraft, missiles and all. Radiators and other heat exchangers. It is not corrosive, so that it is used for radiator and other exchangers. Then electrical conductor, cables, bus bars. So since it is a good electric conductivity, so it is used for electric conductors and cables and bus bars. Aluminum alloy system. Aluminum alloys are classified on the basis of the principal alloying element present in a particular alloy. So that is about the aluminum and its alloys. The application of aluminum. The aluminum is extracted from the ore bauxite. So bauxite is available on the earth. From this ore, the aluminum extracted. So it is a good conductor of heat and electricity and a lighter weight, but its density is very less, 2.7 grams per cubic centimeter. So aluminum is a best material for household utensils and it is also used for electrical conductors.